Okay, technical math final review part 2. Okay, order of operations. So please excuse with the root. Okay, my dear Aunt Sally. Okay, so parentheses. Yeah, you have them. So you have a minus and a times. Well, multiply comes before subtraction. Okay, so we have to figure that out first. 17 times 3 is 51. 253 minus 51 is 202. Now in the other parentheses, it's just adding, subtracting. That's of equal value. That's 101. Divide them, you get 2. Okay. 14 plus 10 times 7, then 4 plus 2 plus 18. Okay. That's an easy parentheses. That's 6. Plus and times. Multiply becomes before adding. 70. Okay, and then 14 plus 70, it gives me 84. So you have 84 divided by 6 plus 18. So no exponents, no roots. Multiply, yeah, you have to divide. Dividing comes before subtraction does. So it's 14. 14 plus 18 is 32. Okay, determine the number of board feet in the piece of lumber shown using the formula. Board feet is T times W times L. T is the thickness in inches, W is the width in inches, L is the length in feet. Okay, T, it's 6 times 18 times 10. And again, that's a parentheses. It's all times. So 6 times 18 times 10 is 1,080. So we now have 1,080 divided by 12. And then that gives me 90. Okay. Board feet equals 90. Okay, more order of operations, this time with fractions. Not a big deal. You can use your calculator, obviously. Parentheses, you have them, just this operation here. So that's gone, and that's 46 over 63. So you have 46 63rds divided by 1/4. And then pretty much just divide them, you get 2 and 58 63rds. Okay, parentheses, you bet, you have times and divide, okay? Multiplying and dividing is equal value, okay? So you just get rid of the whole thing at once, okay? Times and divide, you punch that in, it's 3/4. So we have 3/4 divided by 2/3, and if I divide those, I get 1 and 1/8. Okay, number 6, R1, R2, and R3 are the individual resistances in ohms for the circuit. Determine the total resistance, RT, in ohms for the circuit shown using this formula. Okay, and these are the individual resistors. You find the total. The label's ohms, by the way. RT. So R subscript 1 is 50. R subscript 2 is 20 times 25. Now bottom you have 20 plus 25. Now your order of operations, you insert the parentheses, just one operation inside of each of these, so you just evaluate it. 20 times 25 is 500. 20 plus 25 is 45. So RT, we have 50 plus 500 divided by 45. Okay, no exponents, no roots. Multiply, divide. Yeah, you have divide right there. So 500 divided by 45 is 11.11. You have to round that to the hundredths place. So we have 50 plus 11.11, and that's 61.11 ohms. Okay, fraction to decimal, super simple. Just divide 4 by 5, you get 0.8. Okay, now right here, decimal. 5 divided by 6 is 0.8333, so it's 0.83. You have to apply the 8 in front of it instead of a 0. Okay. Reduce each of the following common fractions to lowest terms. Okay. This one's a pain. I'll explain why here in a bit. So without the 0 and the decimal, you have 7,325. Then place value, you have that's the tenths, that's the hundredths, that's the thousandths, that's the 10,000ths. So it ends up being over 10,000. Now you can ABC that, see how it works, or you could start your dividing process. You'd start with 5. 293 over 400, so that reduced, and that's the lowest terms. Okay, next one. Without a decimal, it'd be 13,255, and then you got 10, 100, 1,000, 10,000, 100,000. So you bet you're going to put that over 100,000, but a problem happens here. Well, that's not going to work because the directions tell me that it needs to be a fraction, okay? Now, on some of the other problems where they don't say it has to be a fraction, you're fine with the decimal, but if it has to be a fraction, here's what you're going to do. I can list numbers 2, 3, 5, 7, and 11. Those are your first 5 prime factors. Can you divide those each by 11? No, that one can, but I don't think 100,000 can. So 11 won't work. Now try 7. Didn't work. Now try 5. This is going to work because that ends in 5, that ends in 0. Okay, so 2,651. Now divide the other one by 5. It will work. We know this because one ends in 5, one ends in 0. 100,000. Or no, wait a second, I didn't do that right. Divided by 5, 20,000. Now can you divide by 5 again? I don't think you can, because you'd have to, yeah. By 3. Nope. Then by, we know it's not 2's not going to work, because that's an odd number. So you have to divide by your prime factors when that happens. So I know it's not real fun, but whatever. Okay, perform indicated operations using round 2 decimal places. So parentheses, exponents, roots, multiply, divide, add, subtract. So the parentheses right here, just the one operation inside. 16.6, okay. So now we have 21.3 divided by 7.2 to the 3rd power. Plus 16.6 to the 3rd power. Exponents, you have them here and here. 7.2 to the 3rd rounded is 373.25. 16.6 to the 3rd rounded is 4574.30. Okay, exponents are gone. Now you got divide and plus. You're going to need to divide first. So when I divide that, I get 0.06 plus 4574.30. I add those and I come up with 4,574.36. Okay, now this one. Parentheses, yeah, you have this fraction, so you have it here and here. They're separate. So I figure this out, okay, and figure those out separately. Okay, up here this division gives me 40.85, I think. Can't read my writing from the other packet. Yep, 40.85. Down here, that gives me 0.84. So we have the 5th root of 40.85 divided by, and the 5th root's only on top, okay? The 5th root is only on the top, not on the bottom. In the original problem, it only covered the top. So the bottom is 0.84, just outside. Now, exponents, roots. Yeah, you have a root you need to simplify. Okay? So I'm going to write over here, fifth root of 40.55. When I punch that in, it's 2.10. So again, this root now is replaced with 2.10. So we now have 2.10 divided by 0.84. And that divides to 2.5. So again, you had to look carefully. The root was just on the top, which is a good thing, okay? Because otherwise I'd have to divide, then do the root, okay? But just on top, so I do the root, then divide. Okay, express each ratio in fractional form, reduce to lowest terms. Now this is a ratio, ABC ain't going to cut it. So you go on a multiplication table, 34 and 18. Those would only be in the second row. So you'd reduce them by a factor of 2, and that's 17/9. Now this one, I know those numbers don't turn up on the table, but they're going to, because when you have a 0 over 0, you can get rid of them. Okay, 54 and 36. So 54, here's 54, there's 36, so 18. Now they're also in a couple other rows, like the 9th row and the 6th row, but I would want to do 18 because it will take it down by the largest amount. That would be 3 over 2. Now, if you do ABC, let's say somebody did ABC, that's fine, but that is not a ratio. That would then need to be made into a mixed number. 1 times 2 plus 1. That's 3. Okay. Okay, number 16. The machine bolt shown has a thread pitch of 1/8 of an inch. The pitch is the distance between two adjacent threads or the thickness of one thread. Find the number of threads in 2 1/4 inches. Okay. Okay. You got to find out how many times the 1/8 goes into 2 1/4 of an inch. It's just a division problem. Don't overthink it. Okay. Story problems here are not too bad. That's 18 threads. Okay. Percentages to decimals to percent. Easy. Move the decimal twice forward. 34. Move the decimal twice forward, fill that in with a 0, and that's 20. Twice, not just to the end, twice. Okay, now you have a percent, you got to make it into, this is wrong, express each. That's supposed to be as a decimal. I screwed that up, I apologize. Okay, now you're like, oh, it's already a decimal. Yeah, but to drop the percent sign now, you got to move it 2 to the left. Okay, 2 backwards. Okay, so 0075, put a 0 in front. Decimal, 2 back. 0.1875, 0. Okay. Percent as a reduced fraction. Well, I know I'm going to have a 20 in the numerator over 100. Now you can divide them each by 20 or ABC it. Either way, it's 1/5. Okay. ABC it, or you can divide them each, starting with probably 5. 25 will work. I mean, 2 1/4 is what you get. Because 100, 200, that's your 2. You have 25 left over 100, but 25 over 100 is a quarter, 1/4. Okay, 36.5 is what percent of 27.6? Set up your percent proportion. Percent, 100% is over of. So the percentage we don't have. We have the of at 27.6 and then 36.5. Then you cross multiply and divide, you get 132.25 rounded. 24, what's 33% of 93.6? Okay. Okay, so 33 is over above. Alright, so it's 93.6, and then to find the is, you cross multiply and divide. I'm going to round to 30.89. 51.03 is 88% of what number? So you got 88 for your percent. Okay. Of what number? That means we don't have the of. Okay, leave that empty. And then 51.03. Cross multiply and divide, you get 57.99. Perform the indicated operation, parentheses, exponents, multiply, divide, at or roots if you have them. Parentheses you have. Now in the parentheses you have times and divide. The times and divide are equal, so you just go across. It'd be negative 9. And then the exponent, it's negative 729. Now this is going to be a negative because the exponent's odd. Okay, if the exponent's odd with a negative base, it'll be a negative product because negative is positive, but then times another negative is a negative. Okay, parentheses please. So you got here and here. You got two operations, a plus and a times. Well, multiplication's the clear-cut leader ahead of addition. So you times first to get 30. Negative 6 plus 30 is 24. Negative 2 times 4 is negative 8. Then divide, you get negative 3. Okay, determine the minimum and maximum values using the supplied tolerance. So this is easy. It's like the easiest problem on the whole test. Minimum, maximum. Minimum you minus, okay? You make it smallest as possibly can be. When you minus, it's going to be 39.994. And it doesn't matter which one you do first on this problem. The maximum, okay, you add, that's going to be 40.006. Okay, find the degree of precision in the range for the measurement, 8.65 inches. The degree of precision, you just have to know what it means, okay? How to round it. It means the degree, you just make everything 0, 0, 1. So 0.01. Now, what's that used for? Well, it's used to find the highest possible measurement and the lowest possible. Because, yeah, it's supposed to be that, but it could be there's an error in the process, okay? You can be up by a certain amount or down by a certain amount, and that's what the degree of precision is used for. So a range, dash, I need to find a number that represents the minimum and the number for the maximum. So you know you're going to take that 8.65 and add and subtract a certain value, but it ain't 0.01. The 0.01 is then divided into half. That's going to be 0.005. Now you can plus. When you plus, you get 8.655. When you minus, it's going to be 8.645. Okay, number 30, the specifications for the length of a part is 1 125 thousandths of an inch, otherwise known as 1.125. What is the least width that would be acceptable for the part? Okay. Set it up like you're doing here. And then the minimum is the least acceptable. That's the answer. Okay. So, least acceptable is the minimum, but I'm going to think of it in the same terms I'm doing this. So 0.001. Now if I was going to find the minimum and the maximum for the range, min, max, you take your specified measurement and add or subtract a certain value. The value you're going to add and subtract is 0.001 divided by 2. Okay, that ends up being 0.0005, 5/10 thousandths. So first off, you would add to find your maximum, and that is going to be 1.1255. Then you minus to find your minimum. 1.1245. Okay. Okay, unit conversions. 37 inches is feet. We're given inches. We got to wind up at feet. We're given 37 inches. So I put 37 inches over 1. Okay. So inches, and then we have to get the feet. There's 12 inches in 1 foot. 37 over 12 is what I end up with. Then you can go ahead and divide that. It's 3.08 if you round. If you want to go second PRB equals and get a fraction, that's okay. Okay, 8 square yards is square feet. Okay, so we have to go from square yards to square feet. How many square yards you got? You got 8. Okay, so 8 square yards over 1. No label required on the 1. It's not a compound conversion, it's just a single conversion. And there are 9 square feet to 1 square yard. 8 times 9 is 72, 1 times 1 is 1, so it'd be 72. And the reason why it's not 3 to 1 is because now that I'm squaring them, then the values 3 and 1 become squared. 800 cubic feet is cubic yards, so cubic feet, cubic yards. Okay, so cubic feet, we're given 800. That's all we have to do, 800 cubic feet over 1. Then cubic feet and cubic yards. Okay, 27 cubic feet, 1 cubic yard. So it's going to be 8,000 over 27. 8,000 divided by 27 rounded is 29.63. Kilometers as meters. Okay, so km to m. We have 4.5 kilometers. Okay, so you got 1,000 for your meters, 1 for your kilometers, times 4,500. That's 4,500. Okay, now fun begins. Last page, though. 8 yards per minute is feet per second, so the yards have to go to feet, and the minutes have to go to seconds, which will take me to feet per second. Okay, we know the yards we're given is 8, the minutes we're given is 1, so it's 8 yards over 1 minute. Well, now you have to make 2 conversions, so you would want 2 unit multipliers. Yards to feet, yard, yard, and then feet occupies the place in the other one. Minutes, minutes, minutes. Remember, it always goes the opposite side than seconds here. So 1 minute is 60 seconds. And then feet and yards, 3 feet to 1 yard. Yards are gone, minutes are gone. 8 times 3 times 1 is 24. 1 times 1 times 60 is 60. Okay, 24 divided by 60 then gives me what I'm looking for, which is 0.4. Okay, 36, don't overthink it. Hot air passes through a duct at a rate of 684 cubic inches per second. So that's cubic inches per second. How many cubic feet pass through in 25 minutes? So we have to go cubic inches to cubic feet. And then we would have to take our seconds to minutes. Okay, which is going to give me my cubic feet per per minute. Now some of you are like, well, what about that 25? That just means you multiply by 25 at the end to get your answer. Okay, that's what that means. It's not that big of a deal though. Cubic inch is 684 seconds. Okay, there's not a number, so it's an implied 1. Okay, so that's 684 cubic inches over 1 second. Cubic inches, cubic feet. So cubic inches, cubic feet. I write kind of small. Seconds, minutes. So seconds needs to go here. You just put it on the other side, opposite side. It's on top, bottom here, top here. Well, I know there's 60 seconds to a minute. Okay. Then I know we got 1,728 cubic inches to 1 cubic feet. Seconds out. Okay, you find the product across the top. The product across the top is 41,040. Product on the bottom is just the 1728. Then you divide and you come up with 23.75, but then that has to be just the end conversion. That's feet per minute. 25 minutes means I will just multiply that by 25. That's 593.75 cubic feet. Okay, so that's all you have to do. Okay, the 25 is not a big deal.